Hi everyone, this is a video today on graphing. So we need to talk about a bit about graphing. We didn't get a chance to get into this. So first section of graphing is looking at constant velocity. So if I have a graph like this, you learned in math class, you remember the term slope. And slope is, in this case, always rise over run. How much it goes up versus divided by how much it goes over. So typically you would have had x and y as your axes, but we don't really work that way in physics because we want to look at position in time. So in this case, at my position over my time, if I look at that, the slope in this case would be how much we change in the x direction, that's the triangle means delta, or change, over how much changes in the t direction, or the x-axis and t-axis. If you remember, we didn't use this formula, but we talked about it. We said that velocity is equal to displacement over time. In this case, the x is our displacement, and the t is our time, so slope equals velocity. So when I look at this graph, if I can find the slope of that line, and the slope will be the same anywhere on it, if I look at this point or this point, and I find the slope there, that tells me the velocity at any point in time. And in this case, the slope is velocity, the slope is the same as it is here. So because the slope is the same means the velocity is the same. If I were to graph it, it would look like this, right? Telling me that the velocity at any point in time, if I line them up underneath each other, the velocity here is, let's say, 2 meters per second. 2 meters per second. The velocity here is 2 meters per second. Now remember, if it's going up to the right, it is a positive slope. Or in this case, if it goes down to the right, it's a negative slope. So because this is a negative slope, and the velocity, or the slope at that point, would be the same as it would be here, a velocity is constant. So if I can find the slope of the line, and I don't need the numbers, I just want to know the general idea. It's a positive slope. That means it has a positive velocity. If it has a negative slope, it has a negative velocity. This position here isn't on the zero like it was in this one. That just indicates where I started. If I started at my house and went west, or if I started at school and went west, it still tells me what direction my velocity is. So that's if you have a constant velocity. What happens though if I have a graph that looks like this? So this one no longer has the straight line on it, so I can't really just jump at it and predict. We do enough of these to be able to jump at it and predict. But for now, we're just looking at this. So I'm going to give you this little bit of information. So draw two tangent lines. What a tangent line is, if I have a circle or a curve, a tangent line is a line that would go along here and just touch at one spot. And it'll only touch at one spot. If it's any bit of a different slope, it'll touch at two spots. So it just touches at one spot. So what we're going to do is draw two tangent lines, look at the tangent lines, and determine whether they get steeper or flatter as time increases, and then determine if they're positive or negative slope. If it's a positive slope, it means the velocity is on the positive side of the axis. If it's a negative slope, it means on the negative side, and I'm going to draw it and explain that in a little more detail. And if the position time graph starts on the negative side and moves to the positive side, it doesn't have anything to do with the actual velocity graph, only with the initial position. So let's have a look at one of these. So here's a graph. It starts at 0, and it goes up, and then it curves this way. So what we're going to do is draw two tangent lines. I'm going to draw a tangent line right here. I'm going to draw a tangent line right here. So that's two tangent lines. So what we're doing is essentially this tangent line, or the slope of it, tells me the velocity. The slope tells me, or you, the velocity, the instantaneous velocity, so the velocity at that point in time. So this is a positive slope, and this is a positive slope because it's going up. So positive slopes means it's a positive velocity. So positive velocity. So when I transfer this to this graph. This is going to be a velocity time graph. When I transfer it, it means my velocities are positive. This is the positive side. This is the negative side. So it should be on the top half of this. So which way does it go? Well, as I look at it, it's a steep slope. Steep means high velocity. And then this one flattens to the point where at the end, it actually goes to 0. So the slope at the end, let's break this down, so flat means low or 0, depending on how flat it is. So as time went on, it got to 0, so I had a high velocity here, a high velocity at the beginning, and a flat at the end. My graph would look like this. The starting point has nothing to do with it. We're just looking at what happens in that interval. So take two tangent lines, just sketch them on quick, and you have two tangent lines, so they would have both have a positive slope, or this one was positive till I flattened it, right? So it's got a positive slope but very low, so that would have a very low slope, so it would have a very low velocity. So as time went on, my velocity decreased. If I had a graph that went down, so it starts here, and then it goes this way. These are my two tangent lines. They both have a negative slope. And this one is flat, or almost 0 at the beginning, and it gets steeper, so it's a negative slope, so it has to be on this side of the velocity time graph. And it's got a negative slope, so it's getting steeper, so it starts at 0 and heads in this direction. So that is how you look at these. We're going to do lots of practice, so if you're not quite sure, we're going to practice this a bunch. Those are the cases. If you have something where you would have two graphs in the same one, so there's another example coming up. I'm just going to move this for a second. If it gets to here, and then it curves like that, for example, then figure out what's going on to this point, and then do the next part. And then it's going to change. The velocity will go down or up or whatever the case is. So do each part individually. So you'll see a couple of examples in your notes. They switch. That's how you look at that. One last piece. If this is my velocity time graph, if taking the slopes gives me the velocity time graph, then if I continue on and I want the acceleration graph, acceleration with time, this has the same slope all the way along. It's a negative slope, which would indicate I have a constant negative acceleration. And if I'm moving in the negative direction and speeding up, you know my acceleration should be negative. So if my velocity is in this direction, and nothing goes in this direction in this graph because that's time. So in the negative direction here, and I'm speeding up, then my acceleration would also be negative, which is on this side of the axis. Hopefully that makes sense. You'll do some practice, and then we'll actually have a look at these tomorrow. Thanks.